All right, let's talk about Linux. In the Linux world, pretty much everything you do boils down to files. But the way the system sees and manages them, well, it's all based on a few really elegant rules. In this explainer, we're going to dive into the 5 foundational principles that'll take you from feeling a bit lost at the command line to feeling totally in control. So, let's get started.
You know, if you've ever stared at that blinking cursor and felt just a little bit intimidated, you are definitely not alone. The terminal can feel like a whole new world, with its own strange language. But once you learn the basic laws of that world, I promise, everything starts to click into place.
And that's exactly what we're going to do today. We are going to walk through the 5 core principles that will transform that blinking cursor from a source of confusion into a tool of real power. You'll be navigating and messing with files like a pro in no time.
Okay, first up, the most fundamental rule, and honestly the one that trips up newcomers the most. In the Linux world, capitalization is everything. So a file named file with a capital F, one named file all lowercase, and file all caps, to Linux, those are not the same thing at all. They're treated as completely unique.
Let's actually see this in action. We'll use the touch command to create 3 empty files that only differ by their case. Then, we'll use ls-li to list them out. That little -i flag is the secret sauce here. It tells ls to show us the file's inode number, which is basically its unique ID on the system. And just look at that output. Each file, Linux, Linux, and Linux, has a completely different inode number. See? To the system, they are 3 totally separate, unrelated files. The big takeaway here is so crucial. In Linux, you always have to pay attention to case.
All right, rule number 2. This is a simple but really profound idea that's right at the heart of the entire Linux philosophy. Everything is a file. Now, this isn't just some quirky habit. It's a core design principle that makes the whole system incredibly consistent and seriously powerful. And this idea goes way deeper than you might think. I mean, of course, documents and images are files, right? But in Linux, directories are also just files. They're special files that happen to contain a list of other files. Even your physical hardware, like your hard drive or USB port, is represented as a file that you can interact with. This consistency is what makes managing a Linux system so cool.
But you know what they say, with great power comes great responsibility. So while you can technically read from a device like your hard drive just like it was a text file, you really shouldn't. Running a command like cat/dev/sta will try to dump the raw binary data of your entire disk straight to the screen, and that will almost certainly freeze your terminal solid. So be curious, but please be careful.
This brings us to a rule that's super important for both day-to-day use and for security. You know, in a lot of operating systems, you trust the file extension. A .jpeg is a picture, a .txt is text. Linux, it just doesn't care. It looks inside the file to see what it really is.
So here's a little pop quiz for you. If I create a file and I name it fake.jpg, does that automatically make it an image? Let's find out.
Here's our little experiment. First, we use the echo command to just put the simple text fake image inside a file that we're going to call fake.jpg. Then we use the magic command file to ask Linux to play detective and tell us what this thing actually contains. And there it is. The file command completely ignored that misleading .jpg extension. It looked right past the name at the actual content and correctly identified it as plain ASCII text. So the lesson here is huge. Never trust the file name. Always use the file command to verify what you're really working with. Okay, let's talk about working smarter, not harder. Instead of copying files all over the place, Linux uses this powerful concept called links, which are basically just pointers or shortcuts. But there are 2 very different kinds, and you really need to understand the difference. So, the 2 types are hard links and soft links. The easiest way to think about it is like this. A hard link is like having 2 different front doors that both lead into the exact same house. A soft link, on the other hand, is more like a sticky note on your door that says, hey, the party is next door. One points to the data itself, the other just points to the address of that data.
So let's set up a quick demo to see this in practice. We'll make an original file, then we'll create a hard link to it, and a soft link using the S flag. And then for the grand finale, we're going to delete the original file and see what happens to our 2 links. And here's the result. Check it out. When we try to read the hard link, it works perfectly. Why? Because it points directly to the file's data, which is still sitting on the disk. But the soft link? It's broken. The sticky note is still there,
but the house it was pointing to has been demolished. This difference is key. Hard links are tougher, but soft links are way more flexible since they can point across different drives.
Okay, our final rule is all about scaling up. I mean, working with one file at a time is fine, but a true command line wizard knows how to manage hundreds or even thousands of files all at once, using really powerful tools like wildcards and brace expansion.
I mean, just look at the efficiency here. With one simple command using something called brace expansion, that's the 1.10 part, we can create 100 numbered text files in literally a second. And with another command, using a wildcard, that's the asterisk, we can delete every single file that ends in .txt. That little star just means match any characters. It's so powerful.
But this kind of power demands extreme caution. A command that can delete 100 files in a flash can just as easily delete your entire project if you're not careful. This brings us to probably the single most important safety tip you will ever learn for the command line.
Before you ever run a destructive command like rm with a wildcard, you have to do a dry run. It's not optional. First, use ls with the exact same wildcard. That will simply show you a list of all the files that are about to be affected. Once you've looked at that list and confirmed it's correct, then and only then do you run the rm command.
Let me say that one more time, because it is the golden rule. The rm-rf command is permanent. There is no recycle bin. There is no undo button. Once you press enter, those files are gone forever. So please, check first with ls, then destroy with rm.
So let's just do a quick recap of the key commands from our 5 rules. Remember to use file to see what a file really is, ln for creating hard links, and ln-s for soft links. Brace expansion for making files in bulk, and most importantly, always do a dry run with ls before using a powerful command like rm-rf.
And there you have it. We've covered the 5 foundational rules that really govern the Linux file system. You now have the core knowledge to navigate, create, and manage files with real confidence. So the only question left is, what are you going to build with it? Thanks for joining me.